Hi, welcome to Concept Based. I'm John Hepworth, and this is the Year 11 Advanced topic. We are in Introduction to Differentiation, and we are doing, what are we doing here? We're doing calculations with the derivative. Now, the last dot point in the syllabus says, identify and apply the product, quotient, or chain rule, or a combination of the rules. So, although you may know how to do the product rule, the chain rule, and the quotient rule, we don't often see it happen, but it does come up as the functions become more complex. If we are looking to do a derivative, we have to do a combination of them to find that derivative. And so this sample question that I've made up here actually has all three of them together. You can see that there's a fraction in the function, so we're probably going to be using the quotient rule. But in the numerator there, you can see there's two functions multiplying together. X is the first function, and then the second function is 3x plus 1 all squared. Now you'll notice that that second function has a power in it, so that we're going to do a product rule on the top, but then there's going to be a chain rule because it's got a power in there. Now, this answer is quite long and quite wide. I'll definitely be zooming in so that you can see the writing, but I just want to demonstrate the method of thinking that you need to have to make sure that as you go through the process, you're actually doing the correct steps. Now, when you look at grouping symbols, and the grouping symbol here is my favorite word in mathematics, not the brackets, but that line in the fraction, which is called a vinculum, my favorite word. The vinculum groups everything together. So it sort of becomes the dominant part. It's almost like the outside brackets. It's the dominant part of what's leading us to think, what do we have to do with this derivative? It is a fraction. We have to start with doing that quotient rule. So we're going to start there. So the derivative of this function, let's get a little bit of space, is equal to, so the quotient rule says bottom times the derivative of the top minus top times the derivative of the bottom all over the bottom squared. Now if you're starting out with this, you may want to write just out the formula, v u dash minus u v dash over v squared, and then sub into the appropriate places. So the bottom is x plus 1. And we run into a problem straight away. Now, I'm putting brackets around x plus 1 because that's multiplying all of u dash. And we run into a problem straight away here at this u dash right there. Because that u dash is going to break up and become a product rule because that's what we need in the top here. So with that being the case, what I do to try and keep my mind right for where we are in this task is I say, okay, I'm just going to open some square brackets because inside here is a product rule. Now the product rule is the first one, so u of this top section where x is u and 3x plus 1 squared is v, times the derivative of the second one. Now, I put dots there just to remind myself that as a product, it's fine notation in mathematics. Now, the derivative of the second one is the chain rule. So we differentiate the power down the front, we write the bracket, and we drop the power by 1, so 2 becomes 1, and then we multiply by the derivative of the inside, which in this case is 3. Okay, so we've done u v dash. We're in our product rule still. So we say plus the second part 1, so 3x plus 1 squared, times the derivative of the first one. Now that's just x, so it just becomes 1. And our product rule is ended, and we've done this first bit of this vu dash. Now we're going to do minus u v dash. Now u is the top of our fraction, so we're going to write that whole thing minus x outside of 3x plus 1 squared times the derivative of the bottom. So the bottom is x plus 1. The derivative of x plus 1 is just 1, so we're multiplying by 1 and we don't have to do anything. And then we need to write this as a crazy fraction over the bottom squared. Okay, so it's the bottom, this was our v, times our u dash minus u which is this whole thing, because then the v dash is a 1. I can put the 1 there if we want, just for the notation, all over this bottom squared, which is v squared. Now, when you get to this point in these questions, when your functions get more complex, you will still be looking for turning points. And that means you're going to try and see if the top is equal to 0 at some point. So in these, you can then go in and try and tidy them up. There's a rule, well, there's a recommendation I make to students all the time when tidying them up, is if there is a common term in this product rule, which there often is, factorize that out first, because we don't want to be doing any multiplications that we don't have to be doing. I'll zoom back in so you can see what's going on. So it equals x plus 1. And then I'm going to take a common factor out of 3x plus 1. And then I'm just going to rewrite what's left in my bracket. And I'm still going to use a square bracket, even though it's going to become less complex. 2 times 3 is 6, and I've got an x there, so it's 6x. And then the next term is the 3x plus 1, but one of them has been taken out, the squared, so it's just plus 3x plus 1 minus our term at the back here. We haven't done anything with that yet. Okay. Now we can tidy up, and it's still all over x plus 1 squared. Now we can tidy this part of the bracket up. We can change 6x plus 3x plus 1 into 9x plus 1. So we then go ahead and write it as x plus 1, 3x plus 1, 9x plus 1 minus x outside of 3x plus 1 squared over x plus 1 squared. Now I'm almost there for this tidying it up in the future that we're looking for these zeros, because look what's in the numerator here. This term and this term are a common factor. So I'm actually going to factorize that out completely and say 3x plus 1 outside of x plus 1, 9x plus 1 minus x 3x plus 1 over the bottom squared. Now, I would continue and go and tidy this up or investigate this part of it to see if there's an ability to set this to 0 as well, or find factors in there. But I know at least I've found one factor here. So in the future, when you're looking to make the top equal to 0, I found it, like negative a third, it's going to equal to 0 there. If we were going to tidy up the middle, now I made this question up. So the ability for this bit inside here to become something, actually let's make it square brackets so we don't get confused. To become something that's usable, a quadratic that's usable, it's highly unlikely. So we're going to have 9x squared plus x plus 9x, so plus 10x plus 1 minus 3x squared minus x all over the bottom squared. And then I'm going to see what this quadratic in here looks like. 6x squared plus 9x plus 1. And when I say I'm going to see what this quadratic looks like, what I'm actually going to see is the discriminant positive? Because if it was, we would have further zeros that will come from there in the future. So let's just have a quick look. So b squared, so 9 squared minus 4 times 6 times 1 is our discriminant. So it's going to equal 81 minus, it is going to have solutions, 24 equals 7757. It's positive. So there are actually going to be some zeros that will come out of here as well. So in the future, when we're doing further calculus and we're doing minimum turning points and we're looking at derivatives and so forth, we could find 3 solutions to the top of our derivative. So it does become that complex. And this is not outside the syllabus, right? This is definitely within the realms. But what's important today in this lesson is this one step here. You have to be able to combine a quotient rule with a product rule with a chain rule. The rest of it is just algebra, right? And we know in the advanced course we may have to do many lines of algebra. But this step, getting this out correctly, is the challenge. I wrote the quotient rule as a guide before I did it. You may want to write the product rule for this part, uv dash plus vu dash, noticing that these will be different v's and u's. These are the v's and u's of the top, not the u and v like this, but the u and v like that, up the top there. So you can use tools in that way to guide you further and further, or you might be able to write the whole thing out like I did up the top there. Now, again, this is a crazy complex level 1 because it has got 3 types in the one, but reading from your syllabus or a combination of the rules. So it definitely is within the syllabus there.